So there are an infinite number of correct answers that you could have used for problem number 2 here. One of the examples we did together was this one. Remember, 1 plus 1 gave us a sum of 2, and 2 is not greater than 2. In order for this to form a triangle, the sum of the two shorter side lengths would have to be greater than the third. Well, 2 is not greater than 2, so this couldn't form a triangle. Similarly, when we had 3, 3, and 7, 6 was not greater than 7, so that didn't form a triangle. Whatever your answer is here, it's just important to check and be sure that the sum of your two shorter sides is not greater than the third. If it's not, then it cannot form a triangle, and that's a good example that you came up with. Based on those examples that you came up with, the general rule that we're saying is that AC plus CB must be greater than AB. If AC plus CB is equal to AB, then you won't get a triangle. Let me show you why. Remember this tool that we were experimenting with earlier? Let's see what happens when we have four, let me make this 3, that'll work, and 3 and 6. Well, guys, 3 plus 3 is 6. And what happens in that case is I end up with 2 straight lines. If I put them together, I don't get a triangle. I just get one line on top of another line. It doesn't work. I can't make a triangle. The sum of the two shorter sides has to be at least a little bit greater than the third. Let me make A just a little bit longer and watch. Now I can make a triangle because 3 plus 4 is 7. And that is big enough that I can bring these together and make a triangle. So when the two shorter sides sum to a number that's equal to the third, that's not good enough. You just get a straight line. The sum of the two shorter ones must be greater than the length of the third. Let's go back to the activity we were working on. We really did some good thinking here. This is a practice opportunity. Here, you're going to pause the video for 5 minutes, and you're going to try these examples with a partner. Now, before you get started, I want to save you a little bit of time. This is a much easier task if you order your side lengths from shortest to longest. What I mean is this. For this one, I should have 2, 2.4, and then 5.1. That tells me that I should add these and compare the sum to the third number. Putting your sides in order will make this a much easier task. So that's your first step. Order your side lengths, sum the two shortest, compare the sum to the third. Okay, I want you to pause the video, set a timer for 5 minutes, work with a partner, and while you're working, your teacher will be checking for understanding. Well, you've hit play, so that means you're ready to talk about these. And our first one, example A, 2 plus 2.4 is equal to 4.4. 4.4 is not greater than 5.1. So these cannot form a triangle. What about on part B? If I add 7 plus 1.9, I get 8.9. 8.9 is not greater than 9.2. So no, part A will not form a triangle. No. Part B will not form a triangle. Earlier, I alluded to the name of the rule that we are using. It is called the triangle inequality theorem. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. We've talked about that before mathematically. We said that in order to form a triangle, AB plus BC must be greater than AC. It's kind of like earlier when I was talking about going to Starbucks on the way to my friend's house. AB plus BC must be greater than AC if you want to make a triangle. And that is what the triangle inequality theorem says. A theorem is just a mathematical rule that you can prove formally. And we could prove this theorem formally. We've proven it informally today. Now, this last activity is for you to do as a group. Your task here is to determine if the given information could be used to form a unique triangle, many different triangles, or no triangles at all. So those are going to be your answers here. A unique triangle means just one. That's what the word unique means. So there's just one. So there's only one possible triangle that could be formed. For example, let's say I had the side lengths 1, 1, 1. That forms a triangle, and there's only one triangle it can make. An equilateral triangle with side lengths of 1. That would be a unique triangle. So in that case, I can only make one. There are some side lengths that could make many different triangles, and there are some that could make no triangles. So your task is to look at these lists and decide, is this a unique triangle? Could this make many different triangles, or could this make no triangles at all? You are going to be working in groups of 3 or 4. This task should take you 10 or 12 minutes. At this time, the video is done, and it's time for you to work with your friends. Set a timer and get busy. Let's see what kind of triangles or no triangles at all you can make with these values.